All right. The unit vector is a vector in the same direction as another vector, but it has only got a magnitude of 1. Okay, unit means magnitude of 1. Okay, so I need to be able to define what that vector would be if I've been given another vector. Okay, so let's have a look. We've got this vector c, which is 6i plus 3j. So we've got 6i plus 3j, and there we go. That is vector c. Okay, so c is 6i plus 3j. That's easy enough. Now the unit vector in that direction is going to be some vector somewhere over here, which has a magnitude of 1. So notice it's going to have some distance along the y-axis and some distance along the j-axis, and we need to figure out what that is. Now the way we do that is we are going to use the magnitude of our vector that we've been given and work with that to find our unit vector. Now remember, our magnitude of our vector c is just the square root of x squared plus y squared, where my x component is my 6 and my y component is my 3. So I'm going to have 6 squared plus 3 squared, and that's going to be root 45. And we can simplify that to 3 root 5. That's the magnitude of my vector c. Okay, now there's a definition. You need to know it. It looks like this. So a unit, the sign for a unit vector is this vector c with a little kapiki on it, which means that it is the unit vector. And we find that by finding or taking our vector c that we've been given in component form and dividing it by the magnitude of that vector. So that's going to be 6i plus 3j over 3 root 5. Okay, and we can split those fractions, so it becomes 6i over 3 root 5 plus 3j over 3 root 5. We can simplify those fractions, so it becomes 2i over root 5 plus j over root 5. Now, that is, mathematicians do not like to leave things with square roots in the denominator, so we have to rationalize it, and it's expected that you do. And so we end up with 2 root 5 over 5i plus root 5 over 5j. And that would be our unit vector in that direction of vector c.